Alright guys, I want to show you an issue that I've been trying to debug for probably the last week. For the longest time, thought maybe it was a test RPC specific issue. Turns out it's a caching issue within the within Ethereum JSVM. In order to explain the issue, I kind of have to give you quite a lot of background. I'm going to do a little bit of that. Uh, it would take too much to go into all the details of Truffle, but so some of the stuff you'll have to take my word for it. If I can find what I'm looking for, there is a contract called rootcontract.sol, and what it does is it has a function called create subcontract, which creates a new instance of the subcontract which we've imported, adds the address into a mapping, adds a number, logs these for testing purposes, and that's it. The subcontract is a contract with absolutely nothing in it. In fact, the code that was there is commented out. A user of TestRPC originally submitted this issue. And so what happens is that I'm going to run the TestRPC in a specific way. So actually just I have a version of the TestRPC on my machine, so I'm running specifically from that version. And we're just going to run it like that. This is a new TestRPC with an HD wallet and deterministic accounts, but well, they're not deterministic by default, and I'll get into that in a second. And then I'm going to run a truffle test, which actually let me go into that test real quick. A lot of interesting code here, actually just mostly for output purposes. The important part of this truffle test is that it creates a new contract, version of the root contract here, puts that on the network. Excuse me. Calls, where are you? Oh, that's up here. Makes a transaction for create subcontract, which should create that subcontract, and then tries to get the address of the subcontract that was stored in that mapping that I told you about. Excuse me again. So when I run this test, I actually have some output of it here that passes, so I'm not going to well, actually, I will run it, but I'm going to go over this output real quick. And so what this output shows is the root contract address. It verifies that contract address based on get transaction by hash. It does logs that I told you about. It gets the subcontract address via the logs. It gets the subcontract address via the root contract, and this is where the issue is, which I'll get into, is that this was 0, and then this was 0 as well. This verifies that the subcontract has code, and then it verifies that the root contract has code, and the test passes. So what I'm going to do is I'm running the test RPC already, and I'm going to run this test. And actually, it might just pass. Oh, it failed the first time. Well, let's go ahead and run it again. That's nice that it failed the first time. Pass the second time. Who knows how long it'll go. If you stick this in a while loop, by the way, I'm running truffle on my local machine, so that's why I'm not actually using the truffle command. And so you'll see that it sometimes passes and sometimes fails, and the error is that the subcontract address is 0. So when we look at this output when the test fails, the contract, the address of the subcontract is 0 in the root contract, which doesn't make a whole lot of sense because it passed before, and we know that this code was working fine. So this is really interesting. What I'm going to do is pull in a log file over here. Let me scale it the right way. This is test RPC output, and I'll show you what I found. This is, well, actually, let me step back. I'm taking it every step of the way. So what I found, before I get into that, what I found is that if I run the test RPC with a specific mnemonic for the HD wallet, that the issue becomes deterministic all the time. So this is going to run until it fails, and it's going to fail the first time, right? And then if I start the test RPC again to get the same state, same nonce and everything, run it again, it's going to fail the first time. So now I've got a deterministic bug, which otherwise seems to be non-deterministic. So this is good. We now have a good state to test this thing in. So if you look at the output, actually I'm getting ahead of myself again. What I did is I researched what was going on. Finally, got down to the process storage request, storage, come on. Sorry. So finally realized that the issue was in this process storage request, where I'm getting a value from the tree at a specific position. Well, first I get the address, then I get the position. This code doesn't really matter so much, but I get the position, and I realized that it was somewhere, or I thought that it was somewhere in here, and this made me want to print out what data. So here I'm getting keys from the tree. This made me want to print out what trees were being set in each transaction, so I could verify that what I thought was being set was getting set. So now that goes into that that output I was talking to you about, and what I decided to do was override. Let's scroll way back up here. Override the put function on the state tree and print out what was being put there. And so when you go and take a look on a, let me get you a different one here. I have two. So when the test passes and the transaction is successful, you'll notice that there are 1, 2, 3, 4, 5 put requests in this transaction. And this transaction, again, if you remember, is the transaction to create subcontract. So there are 5 put requests on a successful transaction. And in looking at, in comparing a successful transaction versus a non-successful version, that's my dog in the background, the non-successful one for some reason has 6 put requests. 1, 2, 3, 4, 5, 6. And if you look at this, what I realized is that this data here, if you stick it into RLP decode, is account data, which has a state tree and everything else. And so, and this is the address of the contract that gets created, the root contract. And so what this is saying is that for some reason it's updating the root contract twice. It's updating the state of the root contract twice, whereas when the test passes, it only updates it once. So this is obviously an issue. Let's see, what do I do next? So now that I know that's updating it twice, I decided to take a look at what part of the code in Ethereum JSVM was actually updating the tree. And it turns out that that's all in the cache. The cache is effectively what updates the tree. Most of the other stuff within the Ethereum JSVM code talks to the cache, which then talks to the tree. So so if I go and look at the output that I have now, where it's currently failing, I've done a ton of printing stuff. In fact, let's go ahead and take some of that out. Give me 1 second. We're going to get rid of that. So remember this is deterministic. I'm going to go ahead and run this test one more time, and you're going to see the output we're talking about. It's going to go ahead and fail. And so here's that same output, but the state of the cache, well, at least the keys inside the cache during this transaction. And I actually had a few other things output. At the start of the transaction, the cache length is already 1. And it's not actually output here. You'll have to take my word for it, but the cache, even before the transaction starts, the cache already has this item in it, or one of these. Note that there are two items in the cache with the same key that represent the contract that was created. So what I believe is happening is that these two entries in the cache represent two different states of this contract. One, the original state when the contract was deployed, and two, the state after which the transaction took place, the transaction that created the subcontract. So what I think is happening then is that the flush code in the cache is going through everything that's in the cache, including the item that was originally there, and resetting that data. But unfortunately, bad ordering happened or something, and sorry, I don't mean resetting that data. Putting that data into the tree, but because of bad ordering, the old data is being put after the new data, and so it's overwriting the data that it's overwriting what it should be. I've verified that if I remove the second put that overwrites the state of this contract, if I remove the second put, things are how they should be, and the test passes. So looked into it further once again, and if we go to Ethereum.js VM, I'm going to go to it on GitHub. Oh, right here, cache, and we look at all the places where an insert happens in the cache. Sorry, this is an insert into the red-black tree that powers the cache. There's only a few places. There's warming the cache, which I don't do in the test RPC. There's this cache put, which does check to see if a node exists already. And then there is this get or load function, which I'm not sure what it does, which does an insert but without checking to see if a node exists already. And here's where, just by guessing, I figured, well, possibly here it's inserting without without checking the current state of the cache. So what I did is I commented out, and my test passes. And so what I'm going to do is I'm going to show you that here, if I can find the code right here. So once again, we're going to show you that we have a failing test for good measure. Fails as we expect. Comment out this code here. Oops. Rerun the test RPC in the exact same deterministic state. Run our test, and we'll see that it passes. So it's going to keep running again, and it's going to keep passing again. What I need to know is whether or not I can actually remove this. Is this cache insertion important? I'm currently running all the tests, of course, in Ethereum.js VM, but they're going to take a long time to finish. So I know this is a super complicated issue, and like in trying to describe it to you, I've jumped around a bit and stuttered trying to get all the information that you need. Feel free to ask me questions. I would love to either find a way to get around this code here, or completely remove it, because it's currently making the test RPC unstable. One thing that I forgot to mention is code like this in the put function that checks for a node existing already. If I copy this same code, modify it to look like this here, where I'm putting the account and exists and false, but checking to see if a node exists before inserting, the test still fails, so my issue still exists. So I'm not sure why that is. I would assume that if a node already exists, it would just update the node, everything would be fine, but I don't understand what get or load does. So yeah, if you guys could let me know your thoughts and where to go from there, it'd be much appreciated. Thanks a lot, guys.